couple of folks that are going to introduce Huawei, and we encourage you to consider hosting Spark meetups as well. We're accelerating the rate at which we host and produce these because the number of projects and the rate of progress in them is also accelerating, and we need to have more meetups in order to debut all of the cool stuff that's happening in our community. Also, since there's a contingent of people who attend from the South Bay yourselves and a separate contingent that attends mostly in San Francisco, we've decided to kind of aim to eventually converge at approximately one meetup in the South Bay and one meetup in San Francisco per month. So that's 2 meetups a month. And we're going to continue to try to stream all of them. And as we work out the bugs, that means that every person should be able to see all of the meetups. And if not via the streaming channel, then via YouTube, where all of them will also be getting uploaded going forward. So first up tonight, we have a short introduction to Huawei by one of the folks who's on the team that's been hosting us. And Huawei sounds like obviously the fact that they're hosting a Spark meetup means that they support the growth of our community.
Thank you, and welcome to Huawei. Thanks for giving us the opportunity to host the Spark meetup. For those who do not know much about Huawei, I'll just give you a short introduction. We are a global information and communication technology player in about 140 countries with 150,000 employees worldwide, and almost half of that are in R&D. So this location here is Huawei US R&D's headquarters, and our mission here is to be the innovation engine for the rest of Huawei, whether it's coming up with new ideas, coming up with new business models, but primarily focusing on the ICT industry, how we can make this industry better. Of course, something like that we can't do by ourselves. We collaborate with outside communities for that. We collaborate with other companies, big companies. We collaborate with institutions. We collaborate with research institutes as well. Just to give you an idea, we spent about $10 million in US R&D working with research institutes, and Berkeley being one of them as well. They didn't get all of it, but yes, we're members of AmpLab. One of our key technology for our labs is big data. Many of our labs are looking at that area. We have considerable amount of work happening in this area, including work related to Spark. So thanks for giving this opportunity to host this one, and we're looking for major progress and major development in this area and want to be a strong participant in this ecosystem. Thank you.
So the speaker tonight is Ali Ghodsi, and he is a researcher at UC Berkeley who's been part of the Spark project about as long as anybody has been a part of the Spark project. And he'll be talking about some of the most exciting cutting-edge stuff happening, including Simmer, which is Spark in MapReduce, and table generating functions in Shark.
Thanks, Andy. And thank you all for coming. Okay, so can everyone hear me? I see. Okay, that's all right. Let's try that. Okay, so this is joint work. So this is work that has been done at the AmpLab. So that's me. But also in both of these talks, one person from Databricks has also been involved. So this is things that Databricks is committing back to open source, and I'm doing it, as part of the AmpLab, UC Berkeley. So in particular, this particular talk that I'm presenting, Ahir helped out here, so he did a lot of the work, and he'll be doing a little demo right at the end of this talk, so I'll just dive in. Okay, so what's the background of Simmer or Spark in MapReduce? So Spark has for a long time leveraged Hadoop, the Hadoop infrastructure. It sits on top of HDFS, and now it also runs on Yarn, so it leverages these things very well. But one of the problems is that a lot of big clusters out there are running Hadoop MapReduce version 1. So they're not running this new Yarn or MR2 yet. And these are big deployments. And to try out Spark on these, it's a lot of work. So in particular, what we typically do and what we've done in the past in the AmpLab is that you send over one of the grad students who cuts out time from their own research. They go there and then negotiate with someone in the company, and they say, why don't you give us, 5 machines or 10 machines? And they're like, okay, yeah. They go through, lots of hoops, and then finally it's okay. You have 10 machines, and then they install, then you install things on it. And then you go to the ops team. You need admin rights. You install Scala, Spark, and so on. So it's a tedious process that can take like months, okay? And it takes a person to do it. So what we wanted to do was to just simplify this. So you want to just run Spark on existing MapReduce version 1 clusters. We want to simplify that. Another thing is that it's generally difficult to try out Spark on many of the clusters, in the sense that you have to configure, compile. There's standalone mode, or you want to run it on Mesos or Yarn. So it can get kind of complicated. So this is why we built this Simmer thing. So what is Simmer? So Simmer is basically just a MapReduce job. So it's essentially a MapReduce job, and inside of it sits Spark and whatever job that you have that you want to run on your MapReduce cluster. Okay? And what it does for you is that it launches Spark, Scala, and your job, and it can also launch Spark Shell if you want to interact with it. So I'm going to show you how it works. But the nice thing about it is that it's really simple to use. So if you're sitting on a MapReduce 1 cluster, you've never heard of Spark, all you need to do is download 3 files, and you just type in a command like this. So you just say /simmer equals -- shell. And that should just be it. That should launch it for you, and you get the Spark Shell, and you can type away Scala and Spark right away. So here we'll do that. So that's the Spark Shell. Sometimes you have your own job that you want to execute that you wrote. So for that, you type something like this. You say /simmer. You give it your jar file, your fat jar that contains all your programs that you compiled, the class that you want to run, the main class, and you can give it any parameters you like. If you want the Spark URL, you type it like that. Okay? So it's as simple as that. Any questions so far? Okay, so that's basically what Simmer is. So rest of the talk, I'm going to just briefly walk you through how this works behind the scenes, and then here we'll demonstrate how, hopefully, I don't know if it's over your phone because you don't have internet connectivity, but yeah, he's going to use his phone and demonstrate this. Okay, all right. So under the hood, what happens? So what happens is that this Simmer that you saw, it basically ships all of a big fat jar that contains all of Scala and all of Spark in it. So it ships that to all the mapper machines. So it's a MapReduce job, right? So it gets a bunch of maps, and it runs, it ships these jars all there. It also ships your jars if you have a job that you want to execute. Okay? All right, so next step, what happens is that once this job has acquired a bunch of map slots on the MapReduce cluster, it's going to set up Spark. Okay? How does that happen? So basically what happens is that all these mappers that are executing, they just write their own ID, their map ID, to HDFS in a specific directory, okay? And we do leader election there. So what we do is that the mapper that had the lowest ID becomes the leader out of these mappers, all right? And that leader mapper executes the Spark driver. So now we got the Spark driver to run. And the other mappers, they just run these executors, okay? So we basically have the driver running, and we have the executors, okay? Now we need to connect these. So the executors need to start talking to the Spark driver. So how does that happen? How do we connect, basically, so we have a cluster inside of this MapReduce job running? Well, so the way it works is that the driver, again, writes to HDFS a URL of its own identity where it exists, the port, and the host name. And the executors just sit there and busy read from HDFS until they see this file pop up. They get the URL and connect to the driver, and now basically we have a Spark cluster set up, and Spark is ready to go. Okay, so that's pretty much it. The only thing that's kind of interesting here, especially with respect to how you execute Spark in existing clusters, is that you're actually launching the driver inside of the MapReduce cluster. So the driver is actually no longer running on the machine where you started the job, but it's actually running inside one of the mappers somewhere in some, in the cluster. So how do you interact with that Spark job? Okay, and in particular, how do we get the shell working? Okay, so the way that works is that we relay everything you see on your screen. So everything you type, we relay it, and everything that comes out of Spark on that particular mapper, we relay it between your machine and there. Okay, so what happens is that we set up basically a relay server, and this relay server is executed on the leader mapper. Okay, so the mapper that became the leader executes this relay server, and the relay client just executes on the client machine, the machine where you started Simmer, where you typed in /simmer. Okay, so you just connect these two, and again, these two need to connect. So how do they find each other? Same way as before. So just use HDFS URLs. You dump them to HDFS, and now the relay client can get the address of the relay server and connect the two, right? Okay, so that leads finally to this. We have this architecture picture basically that looks like this, right? So we have basically, you're sitting on some machine here, and you're typing simmer, okay? What's happening is that it's executing a MapReduce job. Here we have a bunch of slots on a MapReduce cluster. These could be slots in different machines. And what happened is that we happen to get this, and this mapper. These four started competing for leader election, and one of them became the leader. So this one became the leader, executed the Spark driver, wrote its identity to the HDFS, and these other executors connected back to it. In addition to that, we installed the relay server that relays everything back and forth between the client. So you basically get the shell. Okay. So that's basically Simmer. Just a couple of words about it. It currently is already pre-compiled. So we've pre-compiled it and we put it up on the homepage, and you have the URL for the homepage in the beginning of the slide deck. And it works with Hadoop 1.04, which is HTTP 1 to 1.2. It also works on Hadoop 1.2.0. That's HTTP 1.3, and 0.20, which is CDH3, and also 2.0.0, which is CDH4. So that's MR2, right, here? In this case. Yeah, so it also works on this MR2. Okay, so this is a nice way to just play with Spark. If you just want to get it executed, actually, I like it as an approach if I haven't set up anything to just use this. We don't really recommend this for production use, but it's a nice way to just get started with Spark. Also, there are instructions on the homepage on how you can actually create your own jars so that you can actually have your own simmer pre-compiled for different versions of Hadoop. Okay. All right, so demo time.
Can everyone hear me? All right, great. So what I have here is, so I'm logged into a small CDH4 cluster on EC2. I provisioned it on the car right over here, and I did nothing else. I downloaded 3 files. So I'll show you that. So here, can you make your text a little even bigger? Yeah. Yep. I don't know where that went. Is that readable? Yes. Great. So I provisioned this cluster on the car ride over, and I downloaded these 4 files. So I'll just show you really quickly. Let's do this. There we go. Yeah. So simmer shell, launch. So right now the mappers are being acquired and simmer is being deployed.
How many mappers is this again?
In this case, 3. So there'll be 2 workers and the driver. Launching the Spark shell. All right, and that's it. So now you're in the Spark shell, and anything you could do in a normal Spark shell, you can do here. To give you a brief sort of run through. A really simple command. Here we go. And just to nothing too fancy, but this went out, this ran through the executors and gave the result back to the driver, which was then relayed back to your console. And all of this will also end up in the output directory on HDFS, along with most of your logs. So if you're running this yourself or building it yourself, that's sort of nice to a nice place to look, so you don't have to actually SSH to your machines to debug. It just all ends up here. And I'll show you how to run a job. There's a little bit of cleanup that has to happen at the end so it doesn't exit immediately. All right. So this is launching one of these Spark examples. So this is just Spark Pi. Now it's calculating pi. So what has to happen is every time you restart, it has to go and ask Hadoop for new map slots. So it's allocating a new Simmer cluster on the CDH cluster that's already there. So basically, acquiring new mappers takes a couple seconds on each. Yeah. So every time you launch a job, you have to go and it'll go and acquire mappers, and same thing with each shell. So yeah, and that's the demo.
All right, so any questions on the Simmer part? All right, questions? This is pretty messy. All right, I have questions for myself then. Let me see if I can get this up. Okay. All right, great. Yeah, so, okay. Yes, there. Yeah, so there is already a deploy mode for Yarn, which executes, on top of Yarn directly. So you can already use that. This might be simpler to use, but if you have Yarn, you can use that way of deployment. One of the advantages of the way it works in Simmer is that it's launching your driver also inside the cluster. And when you're doing Spark shell, the shell is actually inside the cluster, and we're relaying things back and forth. Whereas the Yarn deployment, I think it's running your driver locally wherever you execute it. And then the DAG scheduler in Spark is talking to the executors that's sitting inside the cluster. Yeah. Another question? Yeah. Okay, so you're asking what happens with scheduling when you launch this, when it's competing with other MapReduce jobs. So this is the scheduling that the job tracker will do in Hadoop. We are just another job, like any other job. So, sorry? Yeah, nothing special, it's just yet another job. It is true that if your job is very long running, it will sit there and hog those resources for a longer period of time. So if you use it like we used it here, it just took those resources for the short duration of the job, and then it relinquished them when it was done. But you could also imagine, if you sit there and, you can take up more. So that depends on the fair. If you're using the fair scheduler in Hadoop, it's going to use the policies that the fair scheduler has. If you use the capacity scheduler, it's those things. So it depends on the scheduler. But yeah, we don't do anything special, and no special treatment for Simmer. Performance? Yeah. I'm a little freaked out that my computer is shut off, but performance of this is not good right now. But no, so in terms of performance, this should execute on par with other Spark jobs. It's just the startup cost is high because, that path, the setting up, is going through MapReduce. So, that gets slowed down, and shipping these jars might take a long time. So it doesn't make much sense if you have very short duration jobs. But let's say you want to do explorative analysis, then you can just set up Spark Shell, and then you have those map tasks. So then those mappers are yours. So that's going to be just as fast as if you launch Spark any other way. Yeah. Yes. Sorry. So that's a very good question. So it's asking if what does the resource consumption look like inside of those mappers? Are we spawning an extra JVM on the side or not? And we're not. We're running it inside of that mapper. So we're behaving nicely like other MapReduce jobs. So that depends on on what you're doing with Spark, but a couple of gigs at least would be nice. But more is merrier. Yeah. Oh, I need to reboot? Sure. Is there an option? Yeah. Other questions? Yeah, please do. Okay, so I have a question for myself also. So Python is also, that's something we're hoping to be able to do with this. It shouldn't be too hard to be able to also get this. And another one would be Shark. So if any of you are interested in helping out with that in the open source side, that would be great. So that you could actually get a Shark shell or you get a Python shell running inside the MapReduce. So that would be something nice. So yeah. So yeah. Yeah, so talk to us if you're interested in helping out with that. No, the main reason is that if you have a MapReduce 1 cluster, a Hadoop MapReduce 1 cluster, there is no way currently that you can actually launch Spark on it if you don't set resources aside. If you don't carve out a piece of that cluster and say, these 10 machines, we're going to install Spark on them, and you can't use them for MapReduce. Yeah. Yeah, so no, Yarn already, there is a way to launch Spark on Yarn today. Yeah, and there should be a README on the homepage, or there is a, if you click on the, deployments, there is this is such a nice mess here. Okay. Any other questions? Yeah, one more question. Yeah. Yeah. So there are a bunch on the homepage. I didn't want to bore you guys and go through all the config parameters, but you can set the number of slots that it takes, and by default, it's like it has a max if you don't tell it, because we were afraid that someone would run this on a 2,000 node, MapReduce cluster, and this takes all the 2,000, mappers. So you can set that. There's an output directory on HDFS where it dumps all the output of the drivers, the workers, all those things, your results. So it has its own HDFS directory where you can put, and you can control that to be elsewhere. and there are some other more configuration parameters you can control. Yes. Yes. Correct. Yeah. Yeah. So I was asking if we're just using MapReduce as a deployment utility or like a resource scheduler. That's what we're doing essentially. It already knows how to launch jars into the cluster and run them as MapReduce jobs. So we're sort of abusing that to get Spark to run on those clusters. Yeah. So it's something to help with deployment. You know, that's what it is. No, it's pretty similar. I mean, you know, yeah, yeah, yeah. It's more for those clusters where you don't have Yarn. Yeah, yeah, yeah. Okay. Other questions? Yeah. Okay.
If you're setting up a new cluster from scratch, how do you recommend? Should I build it up on Yarn or Mesos? Or what would be your
Yeah. So if you're setting up a new cluster and you want to run primarily Spark, is that it?
Yeah.
I don't know if I want to authoritatively say use this or not. I would say don't use if you're gonna use Spark, don't use Simmer, if that's the way you want to do it. I can tell you, you know, I think all three options have strengths and weaknesses. You know, with Mesos you get fine-grained sharing, so that's really nice. So there is a mode in which you get fine-grained sharing, which I think none of the other deployment modes has currently. So that's an advantage. Yarn, there seems to be a lot of applications that use that. And standalone mode, because there is no, you know, hassle currently setting it up. At least for me, it's very easy to just set up those, you know, a master and a worker and connect them, and then you're done. Not lots of configuration that goes into it. But that's my personal preference. I don't want to speak for, you know, the Databricks guys or the, you know, or you know, the Spark, you know, the whole open source. Yeah. Well, essentially you can do that, right? I mean, in this demo we ran 2 separate jobs. You could have run them as one, right? You can just hold on to your Spark driver and do whatever you want with it. Do many RDD computations and so on. And essentially that's what you're doing in the shell. He had the shell open. He could have had it open for 4 hours, right? Until MR kicks you out, basically. Yeah. Any other questions on this? Before I jump into the TGF stuff? Mm-hmm. Yeah. Yeah. So you're talking about. So you're asking if we can run it in long running job, but it relinquishes its resources so others can use it, and then when you type something, it again. Yeah, a longer running platform for MapReduce. Yeah, you could use this, but it would acquire all those resources and hold on to it. So you could use it that way, and just keep those resources. Yeah.
What about reliability? So mappers can fail. So the master can fail. How does that take over?
Yeah, there is no driver fault. Yeah. So what happens with fault tolerance if mappers fail? Yeah. So we actually when it sets up MapReduce itself as a job, it actually disables speculative execution and things like that in MapReduce. So there is no speculative execution happening, and if failures happen, it's not going to also launch another mapper. There's only one attempt. So yeah, you can definitely add that. Yeah, for the driver it's kind of hairy, but for the executors there could be ways to fix that. Yeah, yeah. Okay. No more questions? All right. So let's move on to TGFs then. Okay. All right. So just a little bit background on this one then, TGF. So I'm switching gears a little bit. The first part was mostly a deployment thing. And this second part is more a way we're trying to improve really Shark. So, but to give you a little bit of background, you all already know 2 of Spark's real strengths is that it's really easy to use compared to something, you know, that requires lots of boiler code. You can type these one-liners and, you know, get very far very quickly. So people like that. Another thing that's really cool about it is that it's really fast, right? So those are 2 advantages. But we believe that one of the third advantages that actually gives Spark much of its strength is that it can be a single unifying platform for many of these big data applications that you have today. So Today, we have on top of Spark, Shark running, so you can run SQL queries. If you want to do computations on graphs, it was recently announced that you have GraphX, so you can do things like, Prego-like computations. And if you are doing, CEP or complex continuous queries, there's Spark Streaming. And finally, for machine learning, there's MLlib. So this is nice. You can use just one platform, and it unifies these. But what's so cool about that? It's the same language and so on. That's not going to give you maybe so much benefit. So what we really want to do is we want to make it easy for you to jump between these. So when you're in Shark, you should be able to do things that are over here and backwards, and back and forth. So we want to make that really easy. Okay. So that's the focus of this second thing that I'm going to talk about, TGFs. Okay. So in particular, it focuses on Shark and Spark, making that easier. Okay. So this talk is about this. Simplify Shark, SQL, and Spark interaction, going between these two. That's what we want to simplify. And there are two parts to this. The first part is you want to be able to, from Shark, get things that are created in Spark, okay? And the second part is you want to be able to, in Spark, or in Scala, when you have a, Shark context, or, be able to, interact with SQL in a better way. So we've done some improvements there. There's some better improvements. And in the future, there's this Catalyst project that I'm not going to talk about here. I'm just going to allude to it because it has to do with the stuff that I'm presenting here. You might have heard of it during the Spark Summit. Michael Armbrust talked about it, and I think that he's going to talk about this in a future meetup. So that's it. But I'm going to go through this talk actually in this order. I'm going to start with this one because it makes more sense to understand what's going on in the code. And this talk is a little bit more technical, so it's a little bit more code. So I hope you can see it in the back there. I've tried to make the font big. Okay, so you should tell me, Andy, if this is not working. Okay, all right. Okay, so to start off, we have tables. In SQL land, we have tables like this, right? Columns, and they have types, and a schema, and then you have rows in them, right? So in the rest of the talk, the way we're going to treat these is basically as RDDs of tuples, okay? And the tuples then contain, each of the columns. Here we have a tuple 2 because I'm representing a 2-column table, right? But if you're presenting a 5-column table, it'll be a tuple of 5. And actually, a single-column table will be a tuple 1, okay? All right. So that's from now on, I'll kind of jump between these two. So, tables are, similar to RDDs of this form. And our main goal will be to be able to convert between these two kind of easily. Yes? No, so there is a way to do it with sequences also. Yeah, so the question, yeah, great. I should repeat these. It's like conference. Okay, so the question is there a limitation on the number of columns? And I think what you may be alluding to is that in Scala, tuples can only have 22 elements in them maximally. So there is a way to also use sequences, so you get a list. Okay, so you can do that too. But in this talk, just to make it simple, it's just going to be tuples in the talk. Okay, but if you look at the API, we support both. Okay, let's start with a simple one. So you want to just convert the table that you have in SQL to RDDs. What does that look like? So in the new Shark, basically, we've improved the code so that it actually uses reflection, and it can better infer these types. So this is what the code will look like. This is just a comment, okay? This is just to say someone created a SQL table at some point, and it had 2 columns. One column that's a string with name n, and one that is an integer, okay? How do we actually convert this table that's created in SQL land to an RDD, okay? So the syntax for this is really simple now. That's why these code samples are small. You just say Shark context dot SQL RDD. You give it the types, okay, in Scala. So in this case, the first one is a string, the second one is an int. And then you can give it any SQL like this that you like. So in this case, I typed in freely select star from table, but this could be any SQL or HiveQL query that you run on Shark directly, okay? So it's just going to fetch that, and then it's going to use this, use the schema that it gets back from this. So the Hive schema that you got, and you're going to convert this to RDD of tuples of primitive types, okay? So in this example, it's going to generate this, an RDD of tuple 2 string int, okay? So it's really easy now if you have a Spark context in Scala to execute these and get back RDDs. Right? Questions? On this one, maybe you want to ask if you have short questions, clarification. We can do it here because otherwise, yeah, sure. Okay, I don't know if I know that one. So I think this goes into, I think this is in Shark, yeah, clarification on version numbers of Spark and Shark that supports this. I think this is at least in 0.8.1. And Spark and Shark, the version numbers are synchronized, so I hopefully only need to announce one of them. Okay, good question. Yeah, all right. Okay, so that was that. So we're done with this one. How do we go from tables to RDDs? We know. How do we do it the other way around? Okay, so that's really easy now. All you need to do is provide the table name. So basically, we have an RDD now of tuples of a bunch of primitive types. Okay, and this you created using Spark. So you just created an RDD with a bunch of these, and now you want to turn it into a SQL table, right? So that you can do SQL queries on it. So that just looks like this. It's very simple. This is just commented code. I mean, actually, this looks more complicated than what I actually want to go through. I just want to show you this. I just want to say that when you have an RDD, you can now just say dot save as table. You give it a table name, okay, and a sequence of the column names. Okay, and it just looks at, this is where the reflection comes in. It actually it goes through Scala's reflection, it uses that, leverages that, looks in the RDD and looks at what are the types, converts them to Hive types, and creates a table for you and saves it into a table basically, into Hive. Yeah. Yeah, so this is just Shark. So the question is, how are you saving it? What's the table? What is a table essentially? What are you saving it? And yeah, this is just it goes into the meta store of Hive through Shark. Okay, so it can be accessed from anything that's Hive or Shark, available. So you can jump between these now. Yeah. Yeah, it creates a table too. Yeah. Yeah, there are details on what happens if the table already exists and stuff like that. But yeah, yeah. I think for now, okay, so does it work with all Hive? Yeah, I got it. He's gonna kill me. Okay, there's so many questions, I have to repeat them all. Yes. Okay, so does it work with all Hive data types? I don't think it does right now. I don't think you can, I'm not sure what actually went into the release. I don't remember whether it supports the nested ones, maps and lists and stuff like that. But it certainly covers the basic types like this. And there are ways you can do it, but it will be slightly more complicated if you want the rest. Yeah. Yeah.
Oh, what's the capitalized there doing?
Oh, that's I think PowerPoint who capitalized this. I don't need to repeat. This is a bug in my slides. Okay. Good catch. It's just a comment, so it didn't compile. Okay. All right. So that was that. So that's already two tables. Okay. So now we can actually move on to the actual TGFs, because we basically needed this simple going between tables and RDDs to be able to do TGF. So what are those? Okay, so this is just a nice way to be able to, basically, it's Scala functions that take parameters and output a table, okay? And you can actually call them from, with SQL or HiveQL in Shark, okay? So let's look at what one of these can look like. So, okay. Here's Scala code, okay? We have an object. I mean, we're going to use it as a function object, right? So we have an object, it has apply. So it takes a bunch of parameters, and it should return a table. Okay, so that's what it is. So now you can write your Scala code. You can write Scala code that just, takes whatever parameters it wants, and it outputs a table. Okay, and we will be able to call this then. What happened there? Okay, so you should be able to call it very simply. Okay, let's see. That is the next slide. Okay, so how do we call this thing? Okay, so this was the same as the previous slide. I just copied it here. Okay, so now we have this command which is called generate in SQL. So in SQL now you can say generate my TGF, which is the name of this. You give it the parameters, okay, and it will just execute this, whatever is in Scala that you wrote. Okay, so it's sort of like your UDF, but it's more flexible. It can take any parameters and it can output a table. Okay, and I'm going to walk you through what you can do with this. So right now this is a little bit undefined. I'm going to fill in more details so that you know exactly how this works. Okay, but if you type generate my TGF parameters, it executes that, and you get back a table, just as if you did this select star in SQL. Okay, it's very similar to that, but instead of reading it from a table, it's actually having it be generated by this object function down there. Okay, there's another way you can call this also from SQL or from HiveQL or Shark, is to write like this. Same syntax as before, we just say as, and you add the table name. Then instead of getting it as select would do, it actually saves whatever this thing generated into a table. Okay? So at the very end of the talk, so I'm going to now walk you through a bunch of details, and at the very, very end of the talk, I'm going to give you an example on the screen, which actually, what it does is that I have a TGF, which calls into the machine learning library of Spark and runs k-means clustering on a table. So you give a TGF a table that happened to have a column that had a bunch of numbers in it, okay? And we're going to call into it from SQL and have it do some machine learning, k-means clustering, and come up with some clusters for the rows that we have in our table, and out will come this table that, you know, has those clusters in it, okay? So that's the goal of today, and, you know, that's what I'm trying to achieve here. But I'm going to give you the details of how we can do that. Okay, questions? All right, so let's start with inputs to this thing. So this parameters makes no sense, so I'm going to tell you what that is, and this doesn't make any sense. That's just pseudocode for now. Okay, so let's start with inputs. So when you give inputs to this thing can actually take any primitive types that you like, ints, doubles, and so on. So you can give it any primitive types of this sort. In addition to that, it can also take any RDDs. So if you give it any RDD as an input parameter in Scala that happens to be a tuple, RDD of tuples, then it knows that this is actually a table. Okay? So then it can actually, when you call it, it can then actually just convert the table using those functions that I showed you earlier into RDDs and then call into the TGF. So hence, when you do generate and you call the TGF, you can have as a parameter give it a table name, a SQL table. And it itself knows behind the scenes, because the type of your parameter is RDD, that it should convert this from a table to an RDD, just the way we showed earlier. Okay? So it would look like this then. So for instance, in this particular example, my TGF, this particular TGF that I've written, which is just an example, takes a table, input table, that is a table of 2 columns. The first one is an int. I don't know why this should be capitalized, and a string, okay? And it also happens to take a second parameter, this TGF, which is an integer, okay? And I'm gonna actually use these. Again, this should be capitalized. I'm slowly building up to my k-means thing that takes a table, runs a k-means clustering of k clusters, and returns it. Okay? Questions? Okay. Okay, let's go to the output. So how can this thing actually output the table? Okay. So when you output the table, you need to do slightly more than what we showed you earlier, because tables actually have names and they have a schema, right? And RDDs don't have a schema. So that's kind of been the big elephant in the room that I haven't mentioned anything about. Okay, that's what I'm going to do now. All right, so the output must be of this type, which is now defined as RDD schema. What's RDD schema? RDD schema is basically has 2 things in it. It has an RDD in it, okay, and it has a schema that describes that RDD, okay? And the schema looks really simple. The schema is actually just a string in a very similar way that you define when you do create table in HiveQL, when you create tables. So it's the same schema definition that you have in that DDL. So let's look at it. So here's how you create, if you had an RDD that you already had generated, and assume it had 2 columns, one string column and one integer column, then here's what the schema looked like. So you just say RDD schema, you give it the RDD, and then you give it a string like this. Name of the column, so you can name columns now, and the type, comma, name of the second column, and the type. Okay? Questions? Yeah. So this thing, so is it RDD, or is it RDD schema, or is it schema RDD? I'm not sure, but it's called RDD schema. So what it is it contains both. So you can see it's an object that actually wraps both. It's not just a schema for an RDD. Yeah. So it's not just a schema for an RDD. So it's a good question. Yeah, I know. Yeah, yeah. Are you referring to Catalyst? Oh, yeah. Okay, yeah. So okay, in Catalyst there is such a thing, and it has the names the other way around. I'll come back to Catalyst in the very end of the talk. So it's a good question. Okay. All right, so I think this is sort of the last slide. So let's look at the massive example that I was alluding to all along. Okay, so let's look at this. Okay, so apologies if this is too hard to see in the back, but this is what it looks like now. Okay, so we created an object called k-means. We import machine learning library of Spark, in particular the clustering algorithms that come with Spark. Okay, we have an apply function that takes an input table. This input table should consist of 2 columns, a string column and a double column. Okay, and string, let's say that's like product name, for instance. Okay, and let's say the double in the second column, let's say that's sales, how much you sold it for, or something like that. Okay, that product. Okay, and it takes another parameter. So the apply takes input and it takes k, which is an integer, which is the k that you use, you know, to do k-means clustering. How many clusters do you want? Okay, and what does it do? This first line here is just a way to just remassage the data into an array, just to have each of the elements boxed around an array, because that's how the machine learning library looks like. So it's just boilerplate. You can just ignore it. But what we essentially do is we take basically this input, which has been transformed into data. We give it to the k-means trainer. We tell it that we want k clusters, and these are some parameters to k-means clustering that I actually don't remember what they stand for. It's like number of runs and a bunch of other things that k-means clustering takes internally. Out comes a model. Okay, so this is just ordinary Spark machine learning library, right? Okay, so we got the model. We go back to the input, the very input, and we run a mapper that runs through all of the lines in the RDD in parallel, right? This is all parallel code, and runs the model and tries to predict which of the cluster each row will end up in. Okay, so we first trained the model, okay, and now we're using that model to predict for each of the rows which of the clusters of k-means clustering does this row end up in. Okay, and out comes a new RDD. Okay, now we want to return this new table that actually has each of the rows now has the name of the product, and as a second parameter, it has which cluster it belonged to after you did k-means clustering, and that's this line. So we return to RDD. This is just some typecasting because you expect it to be of type RDD sequence here. And the second parameter is the schema. So this was the RDD schema I mentioned earlier, right? So we need to give it the schema. So here I've given them really horrible names. The table will have first name in the first column will be N, and the second is D. These horrible names are just so that this line wouldn't wrap around here. Okay. Type of the first one is string. This type of the second one is double. Okay. So that's it. And how do we call this thing? You just type now inside of Hive, or you type the SQL query into Shark. For instance, the Shark shell. You just say generate. You give the name of the TGF, which was k-means. You give it your table. So it's a table that you have in Shark, which had those 2 columns. You give it the k parameter. In this example, I want 5 clusters. And I say, save the output of whatever this thing generates after it runs in parallel on the cluster k-means clustering into table 2. Okay, so basically now we can in SQL land make very, very easily these calls right into Spark and get machine learning out of it. And we're considering right now wrapping a lot of the library that exists into this TGF, so it'll be really easy for you to call them simply from Spark or Shark. Yeah. This doesn't, okay, so the question should be repeated. Okay, this input, you said this doesn't match, there's something here. Because of the names here or what? It's just a tuple. So it's just a tuple of 2, right? That just takes 2. These are just names, it could be anything. It's just the names of the. No, it just needs to map on whatever the input is here. Input here, let me see, string and double. So we'll take those 2, right? So whatever the string is, it goes into this, and whatever the double is, goes into that. There might be a typo, but I think it's, so these worked when I ran them in my, on my shell. Then I copy-pasted it, and things might have happened, but yeah, should work. We can look at it on my machine if you want. We can take it offline, and if it still doesn't work, yeah, okay. Sorry? So this has nothing to do with TGFs. Okay, so the question is, this line here, K means train, is that sequential code or is it parallel code or distributed code? So that's irrespective of TGFs, but the answer is that it's running in parallel on like a Spark job. It's doling out these tasks, DAG, scheduler, the whole thing, executing on my executors and all that. Because this is part of the K-means cluster. So K-means here is part of the K-means clustering library, the MLlib library of Spark. Right? So there's a machine learning library in Spark that has a lot of these algorithms, and those are already all parallel. So this thing is parallel. Yeah, so here, it's a pretty simple thing, but lots of parallel code gets generated, and a lot of, so this is simple machine learning, K-means clustering, and then calling it from SQL, and that's it, yeah. How do I pass Spark code to Shark? I mean, okay, how do I pass Spark code to Shark? You just do these conversions that I showed in the beginning of the talk. So define which part? Oh, so these you can generate. You can define them yourself. Okay, so how do you define these, or how do you get these into Shark? Like, how does Shark become aware of code that you've written like this? Right? That's a good question. Okay, I didn't quite get it until you repeated it. The way you do it is you can create your own jar with this, compile this, create your own jar, and then you just say load library in the Spark shell, for instance, and then it's aware of them. Yeah, so there are multiple ways to do that. Okay, before I take another question, let me go through my last slide, which is very few items on it, okay? So at the Spark Summit, we mentioned the Catalyst project, which I think someone was alluding to earlier. And there we're going to further simplify these things. So that's something that's going into Spark, and that's going to give just more support to be able to do more queries, basically, inside of Spark directly, okay? So in particular, everything that I showed you earlier, instead of having to type generate like this and having a special command for generate here, what you will be able to do in the future is something along these lines, okay? You'll be able to just say SQL and then quotes, and then you can type your SQL, and in it you can have a $sign RDD, okay? And this is just at any RDD. So what it does is it just takes that RDD and converts it into a table, right? So it's basically syntactic sugar for what I showed you on the previous slide. So in the future, it'll become even easier. This is not there yet, so we're experimenting with this right now. And this is kind of this is a simple wrapper or simple syntactic sugar, but actually behind the scenes, there's a lot going on. So this is using string interpolation in Scala 2.10. And in particular, this is actually using the macro functionality, which is in Scala 2.10 and 2.11. So what happens is that you're actually inside of a compiler, and it gets this string as a abstract syntax tree, and it then manipulates the code to generate whatever we needed in the previous slide, as you saw. So it generates that behind the hood and then executes that for you. But we're not yet there, and hopefully there'll be a meetup talk on this later by Michael Armbrust. So that's it. Okay, so that was the last one, so thank you. Okay, let's take a couple questions maybe, yeah. So I mentioned SQL RDD command in Scala. Is there something similar to that in Python? I think there is a wrapper so that you can call it, but I don't think you might not get these type things, but you don't need it since it's dynamically typed. So yeah, you can make calls into that, I believe. Yeah.
Would you recommend that to actually access Shark instead of using Python and using like Swift as a driver go to Shark?
Recommend which one? Okay, so would I recommend the Thrift or just use the SQL to RDD directly in Python? I don't have a recommendation there. I'm not sure which one would be better. I guess the Python one, if you run Python, if that works, it's just using Py4j. So Py4j is just a local socket, right, into a JVM, and it can just launch it via that. So I think that would be faster than using something Thrift-based, but could be wrong. Yeah. 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 So okay. Hard question to repeat. It was long. So the question is, I think, why convert between SQL and RDDs? They're essentially the same thing. Sorry? Yeah. So the idea is, so why would you use this? The idea is that, data scientists find it easier to write HiveQL code or SQL type of code oftentimes, right? It's shorter. So this is a way to give them access to maybe something more complicated that actually you can't do. I mean, it's hard to write pure machine learning directly in SQL, right? So this is a nice way for them to get SQL users to get the advantages that you have in the Spark platform. Graph computations or, machine learning. We picked machine learning here, but let's say this was a graph computation or something else. You get all those advantages in SQL, and you don't need to code any Scala, or you don't need to code any Python or anything. You can just stay in SQL land. So that's the advantages. Yeah. Yeah, I can't hear the question. Maybe we can take it offline. Okay, thanks. Yeah.
Last question.
As can you use TGFs as Hive UDFs? Ooh, that's a good question. I don't think so. Yeah, unfortunately, I think all this code that we wrote is not there. So yeah, it was the last question, but one more question. Yeah, why not?
Going along the same line, right? So is there any effort to write a machine learning code using UDF instead of going through TGF?
Is there any do we have the goal of creating a machine learning UDFs instead of TGFs, basically, or providing that? No, I mean, this is one of the reasons we did this, is that it seemed very cumbersome to do it with UDFs, and we looked into the UDA, UDAFs, and all those different versions of user-defined functions in Hive, and we couldn't do something like this simply, and especially also having this conversion be as seamless as possible for the user, because you want to be able to jump between these different platforms on top of Spark as simple as possible. So, we tried those, and we did these in those first, and it seemed that we needed something else to be even simpler. Otherwise, we would have preferred that. This was just a lot of extra headache for me. Yeah. Okay, so that was the last question. Thank you.
All right, thanks, Ali. A couple more announcements, and then a final word from our host. I just wanted to announce that Spark 09 is finally official. The release became official a couple of days ago. I think the vote closed. It has improvements to MLlib, the Python support, Spark streaming. It has support for Scala 2.10. It's an alpha version of GraphX ships with it, which maybe many of you have seen here at meetups, which was kind of pre-alpha until this point. And maybe most importantly, it's our biggest, most ambitious release to date, with over 83 people contributing code. And even though it went up significantly in the number of contributors, the time since last release has gone down. So that's just all positive signs of growth. One more announcement that I'm even more excited about is that we've finalized the dates and the location of the next Spark Summit. It's going to be June 30th to July 2nd, spark-summit.org. You can see all the details. You can now register. We had 450 people come to the last one. We were aiming for 300. We're aiming for 900 at this one. And it's very anxiety-inducing for me to state that number publicly. But the way our community typically works is that we set a bar, and then we all work together, and we overachieve that bar. So let's hit 900. A positive sign is that before registration was open, since the last summit, which is less than 3 months, we had a Google form up that let people pre-register, which means that they sort of just want to be notified. We've had over 360 people pre-register via that form, which is now closed since you can go buy tickets. So please go buy tickets and then immediately tweet and make a Facebook post about this so that everybody you know is interested in buying tickets. We're doing our very best to keep ticket prices extremely competitive, actually much more it's not even a competition compared to like a lot of other big data conferences. We want the ticket prices to be very low so that people at startups and people who need to pay for it out of their own pocket can actually afford to do so. And that kind of we see as a characteristic of being community oriented in the way we run our events versus sort of like commercial oriented where we expect that everybody has a company that buys them $1,000 or $2,000 ticket. What else? So again, oh, and finally, like the last summit, since this is a community event, we want people to consider submitting talks, especially people who are watching and streaming and everybody here. The meetup crowd is the perfect group of people to actually provide the content of the community event that is the summit, and it's going to be big, so it'll be an opportunity. We've had several launches at the first summit. We're expecting to have more product launches with startups showing off what they're doing with Spark at this summit. And so consider submitting a submission or submitting a proposal for a talk. We'll have a program committee like we did last time, which is selected from the core contributors of the community of the actual software itself. So your submission will be evaluated by the people who are writing the core components, and it's a pretty big group representing like I think over 12 or 15 of the companies that have put real money and energy into making Spark, and not just companies, startups and individual contributors as well that make Spark what it is, and the components of Spark beyond just the core Spark. The submission form is not going to be open until February 14th, so it gives you time to start thinking about what you want to submit. So Spark 09 is now in the past. 1.0 is being planned. If you're on the dev list, then you saw Patrick Wendell's email today about the updates that we're making as we iterate on our release process, so that 1.0 will come in approximately the same sort of timeline, but with an even more ambitious objective than 09. So keep an eye out for 1.0, which is going to be, of course, cause for celebration for all of us, since a major version number change hasn't ever happened in our history. All right, so that's all the announcements. Please come to future meetups. Please come and talk to me or anybody or Scott, who's helping us run these things, wearing the red back there, if you want to host one of these. And then you too can come up just like Zhang Hu will right now and give a word for why people like yourselves should be interested in working for companies that love Spark.
Okay, I just want to say, give two messages. Number one is Huawei is a big company, but we have a lab here we call Software Lab, where we do system things, including big data and operating system and other things like SDN. So that's my lab, and we are the real sponsor of this activity today, and we're also the sponsor of AMP Lab. So I attended the first one of the AMP Lab retreat in 2010, and then I convinced my boss to give the project for AMP Lab. So since then we worked together with Berkeley for quite a while, and it's a very interesting work, and we will continue to work with Berkeley and also Spark. It's a very interesting project. That's the first message. And the second message is we are looking for interns and also senior engineers and researchers. Thank you very much.
All right, so the next meetup I don't think has been scheduled, but keep an eye out and hope to see you there.